Walk around, but I'll try to stay still. All right, thanks everyone for coming this morning to the vMUG. I'm going to be talking about DR options in the cloud, and specifically I'm going to be talking about either physical bare metal or a VMware environment you have on-prem, and how to leverage the public cloud as a viable DR option. So, first about who I am. So my name is Kenneth Hoy. I am currently a technical marketing engineer at a company called Rubrik. If you're interested in finding out more about Rubrik or have questions about the talk after the talk, feel free to come to me afterwards. Come to the Rubrik table at the expo hall, or you can see there are various ways you can contact me. Twitter is probably the best way to reach me at this point. So before we start talking about what it means to have DR in the cloud, let's talk about what is a disaster. So disasters can come in different forms and different scales. I was here in New York and working during 9/11. And during that time, a majority of companies that were in the downtown area were not able to get back to start their businesses for 30 days or more. And all studies show that businesses that were not able to start up within 30 days, roughly 80% of them completely folded and was never able to restart again. So that's obviously a major scale type of disaster. But disasters can come in smaller forms as well and still have a very big impact. For example, I worked at a company where a firmware bug that existed in the production storage arrays actually caused 1 hour downtime to the trading system, during which time the company lost hundreds of millions of dollars in revenues. And once the news went public, the stock actually declined by 2%. Which wiped out a couple of $1 billion of value to the company. And that was, again, a small firmware bug in a couple of storage arrays. So it's important when we think about disasters to say a disaster could be a server or a storage array, or it could be something as big as an entire region or a city or data center going down. In any case, our job in IT, right, is to figure out how do we help our business recover in the event of such a disaster, big or small. So how does the cloud help us in addressing this? So that's two things in particular I want to talk about. One is in the area of flexibility. So because of the way the cloud is, the fact that it's spread across many geographical regions, the fact that it has many different types of services, and also can be consumed in different ways, it creates a flexibility that you couldn't do traditionally with a DR site in terms of what you can create, the different types of options and scenarios for DR. And also, along with that, it also addresses the cost model in the consumption. So if you think about it, if you talk to the business and said there's no money, you don't have to pay for anything, they'll always want 100% the best DR possible, right? But the reality is very few of them want to pay the cost of having the best DR possible. And therefore, especially since if you think about it, in a traditional DR environment, what happens is you have to invest in facilities, equipment, people, time for a site that will seldom ever be used. So it's similar to the idea of why people don't pay for additional life insurance, right? So probably all of us have some life insurance through our companies, but probably few of us actually have adequate life insurance because we don't see the value of paying for it when we don't expect to really use it in our lifetime. So, but the flexibility that I talk about with the cloud also one of those flexibilities, we have different scenarios and different options for how we can create a DR scenario. So in this quick session, I'm going to talk about four options that AWS talks about. Keep in mind, though, that there are very many variations that you can create off of this. And also, though AWS is the example I use, those same principles and same architectures can apply very easily to Azure or Google Cloud. So when we talk about creating a DR solution, besides cost, there are two other things we have to address, right? One is recovery time objective, and the other is recovery point objective. So recovery time point objective, the overriding question is, how much data are you willing to lose? right? Are you willing to lose 1 hour of data, or can you not even lose 1 minute of data? What is the financial impact if you are a shopping site and you lose everything that all your customers' shopping cart, the items they put in their shopping cart for the past 2 hours aren't accessible anymore? What's the financial impact of that happening? Versus, like I said, the trading system that my company had, where they were unable to perform trades for thousands of customers for 1 hour, and lost all their trade requests. And then recovery time objective is how long does it take for you to actually resume business? So this is not just how long does it take for me to recover my data and get it up, but actually how long can I take before that data is usable and I'm able to resume normal business? So a good example is 9/11. If you recall, the New York Stock Exchange took 3 days, or 2 or 3 days to get back online. What most people don't know is that actually the New York Stock Exchange was ready to go back online the next day. The problem was that one of their key partners, who were 1/3 all the trades actually flowed through that bank, they had their backup site 3 blocks away from their primary site, which are all downtown near the World Trade Center. And as a result, it took them 2 additional days to actually get back online. So even though the stock exchange was ready the next day, they had to wait 3 days to actually come back online. And during that time, there was no trading for 3 days. So you can see, so for them, even though they were back online right within a day, the actual recovery time for them was 3 days worth. So you need to think through those things, because that not only impacts the architecture which you design for your DR, but obviously it involves costs, right? The lower the recovery time objective and the smaller the recovery point objective window, the more costly the solution is going to be. So this one I'm going to run through those 4 scenarios and briefly kind of explain what those are. The first is the traditional backup and recovery that probably all you know about, but except we're going to talk about this in the context of the cloud. So traditionally, you would take backups, maybe keep some of the tapes in another data center. Many people will ship them off-site, maybe to an Iron Mountain, and then try to recover them, bring them back for a recovery scenario. So one of the things that we can do now is we can actually archive those data or send the backup data off to a public cloud storage service. Typically would be an object storage service like S3 for AWS, blob storage for Azure, or nearline storage for Google Cloud. In any case, in this scenario, what you're doing is you're actually putting the data inside S3 using either in some cases, a homegrown solution like scripts using async is one option, obviously not very robust. In other cases, you could use a native cloud tool like AWS Storage Gateway or AWS Snowmobile, or you can use a off-the-shelf backup data protection software or appliance such as Rubrics. In either case, the goal here is to move all that backup data into the cloud, where it can be leveraged for a DR scenario. Once all that data is in the cloud, what you can do is basically you have an environment where you're ready to spawn VMs in a disaster scenario. So in this case, let's say a disaster is being declared. What you would do is you would actually launch VMs, either creating them from scratch, or in some cases you can actually convert, say the VMDK, the VM images you've made in VMware, convert them to whatever image a particular cloud is using. In this case, it would be an Amazon machine image. And you can use that to launch some EC2 instances that mirror what you may have on site, and then you would restore data onto those data volumes and resume business that way. Obviously, this is probably the lowest cost solution, because all you're paying for is initially is the storage, which is deep and cheap, and you're only paying for the server instance resources when you spin up in a disaster. Also, but the trade-off, obviously, this takes the longest to do a recovery, and you're going to have potentially multiple hours of data loss. So it depends on what you're willing to trade off. It is still faster than doing it from tape, but not as fast as some of the other scenarios we talked about. The next one is what we call a pilot light. So the pilot light is basically, think about in your oven, you have a little light that helps you to basically light either your oven or your furnace. So in the pilot light scenario, similar to the backup recovery scenario, you're going to move some data into the cloud. But instead of just launching VMs as you need them and create them, what you're going to do is you're going to actually create VM images of what your DR site needs to look like. And you'll either have them as templates that are ready to launch using an orchestration tool like CloudFormation, or you may even have them up and running, but then have them shut down so that you're not incurring the cost of the VM being up. You are incurring the cost maybe of the block storage volumes for those VMs. And the cost of that's getting a little cheaper all the time, so that may be a good scenario. So the advantage of doing this is when in a disaster, it's actually you're actually getting the machines up much more quickly. And also in the case, you're not actually recovering any of your data, because what's happening in a pilot light situation is that pilot light is essentially core components where the state needs to be updated, typically like a database, and you're doing some kind of a replication from your production site to the cloud so that data is always updated and available. So all you're really doing is spinning up these VMs and configuring them to connect to that database, that core components, and then redirecting traffic. So this is a much faster time to recovery. Your recovery point objective window is very small because you are doing periodic or continuous update of your state. But also the cost is high because you do have some components that are continuously running in the cloud at the same time as production. And so here's the recovery that I talked about. And then the next one is similar, is what's called warm standby. So in a warm standby, it's similar to a pilot light, except that not only are you keeping these core components updated, but you also have actual machines that are not just shut down or templates ready to spin up. You have actual VMs that are running in the cloud, but it's a scaled down version of production. So it may be something, maybe you negotiate your business that at initial DR failover, I can handle 30% of the traffic that I had in production. So essentially you would flip the switch using and redirect all traffic in a disaster and run 30%, take a 30% load, and then you would rapidly scale up more VMs as you need them, resize the database as you need it, so that you can take on 100% of the load if that's what you've negotiated. So again, this is clearly a much faster time to recovery. And again, the recovery point is window is very small because you're continuously replicating. And the cost though is high because you are running now not just the storage, not just maybe the EBS volumes that hold some of the images, but you're actually running a subset of your production environment in the cloud. And the last scenario I talk about is the hot site scenario. So in this case, you're literally running a full secondary production environment in the cloud that mirrors what you're doing on site. In this case, you would need synchronous replication between any core components that need updated state. And you're running as many VMs potentially as you would be running in production. And what you're doing is you're either doing a active passive where one is just running in parallel, or you could potentially run a active across both environments. So obviously this is the fastest, this is the state-of-the-art, fastest recovery time, best recovery point, but also the highest cost because you're running a side-by-side environment. So, and that's what the recovery, literally all you're doing is flipping DNS so that all the traffic gets redirected to the cloud site. So obviously, I ran through this very quickly. I have a full-blown presentation that runs through more technical details on how to create these various environments and specific use cases that maps each of these scenarios. So if you're interested in learning more, hearing about that, let your VMUG leader know so they can ask me back. So thank you.